Okay, so now we're gonna talk about sources. The sources can be ores, partially processed materials, and also recycled materials. In this video, I'm gonna explain about what is ore. Ores is a mixture of materials or one or more which can be economically exploited to become a source for supply of a particular materials. So we can see um, in this uh, in this table, ores can be a sulfide, for example, a nickel sulfate, a PBS, a zinc sulfide or sphalerite. Can be oxide or hydroxide, for example, iron ore or titanium dioxide ore or alumina or bauxite. It's also in the form of oxide and hydroxide. It can be halide or salt, sodium chloride, potassium chloride, or fluorspar, CaF2 is the halides, and carbonate, magnesium carbonate or calcium carbonate, dolomite is a example of carbonate. A sulfate, for chromate, molybdenate, tungstate, phosphate, silicate, and all of them are the types of the ore. So the main ore usually is a compound. Now, what is the difference of ore body and mineral deposit? For ore body, is usually economically exploited, while the mineral deposit it hasn't been economically um, feasible to be exploited. Okay, so this is a summary of major source of metals. Magnesium, the abundance is about 1.3%. You can see it on seawater or dolomite. The commercial product can be magnesium or magnesium oxide for chemical industries or for alloys and metallothermic operation. The second one is aluminum. It is quite abundant in the earth, about 8%. The principal source is in bauxite. It is used a lot to make Fe alloy or alumina or aluminum sulfate, okay, or for steel additive as an alloy or chemical equipment. And nickel is a very few actually in the earth as a pentlandite or laterite or about 0.016%. The commercial product is nickel. It is a very good ingredient for stainless steel or alloys. Copper in chalcopyrite or bornite used for commercial product is copper or copper oxide. It's used for the copper itself used for electrical and thermal conductor. Zinc, we saw that a lot in zinc blend or zinc sulfide or calamine. Zinc carbonate. It is used for galvanizing and also for the alloys. Iron and steel as a hematite, magnetite, and limonite. The commercial product, of course, iron and steel, and then used in many construction materials, and there's a lot of application of it. Lead, usually for solders and alloys, made from the principal sources is galena or PBS, and the commercial product is PB. Right, this is the picture of iron ore, and the right hand picture is the hematite at Brazilian mining. This one is the picture that I took from Wikipedia about cuprite, C2O, chalcocite, and chalcopyrite, CuFS2. Uh, and this one is bauxite. This is the bauxite conveyor and stockpile from Alcoa. And you can see the difference. So if we, so bauxite is processed using a Bayer process, and the refined product is called alumina. Alumina is Al 2O3. And alumina is used for the principal raw material to make aluminum through electrolysis process. In the later module, we will learn why we need to do alumina we need to process alumina in electrolysis way, not in pharmaceutical way. And then another one is gold. We can see gold in dispersed in other rocks materials, or sometimes in this gold nugget. This is my picture when I was in Melbourne, Australia, in Ballarat. There used to be a gold mine city, and then it was the replica of the picture of the gold nugget. Right. So, what is the macro characteristic of the ores? We need to know the characteristics so we know what to expect to how to process it. The size and the depth of the ore below the surface will largely influence the characteristic of the ore, the orientation relative to the surface, the integrity, and the presence of geological faults and geographical location as well. So this actually will be some of the major characteristics that we need to know. Usually the geological engineers need to know it is feasible to mine or not. The macro characteristics of the ores largely influence the method which are required to remove the valuable material from the ground. The design of the mine is principally the responsibility of mining engineers as important factor to determine the mining cost. A part of micro characteristics of ores, there are micro characteristics that also very important. For example, the phase presence and their chemical composition, the volume and mass fraction of each mineral, a grain size, a size distribution, a shape of the grain, microstructure of mineral grain, and distribution of grains within the ore. Micro characteristics influence the method which can be used for physical and chemical processing of the ore. The grain size and mineral phases can have a significant bearing of the choice of processes which may be used. The microstructure of the grain define the distribution of the phase within grains, and it is important to define the continuous and isolated phase in the structure. It can be explained a particle physical and chemical characteristic of the minerals and can influence the choice of mineral separation technique. So all these micro characteristics of ore will influence the choice of what is the separation technique that we need to do, what is the physical process, or what is the chemical routes, the hydrometallurgy, pyrometallurgy, or the electrometallurgy that we need to do to select and to design, of course, based on the feasibility and also the economically thinking about that one.